Okay, here's one diagram that indicates the given information. We've got a circle with center at O, diameter BC. We've got a chord CD, and we have a radius that's parallel to chord CD, radius OE. And I'll supply the reasons for these statements, but I didn't write them down. So we're going to let x equal the measure of angle EOC. That's a central angle because its vertex is at the center of the circle. That means the arc that it intercepts has the same measure. So arc EC is also x. The measure of angle C is also x. It's an inscribed angle. Now, why is that true? Because these two parallel lines are cut by the diameter transversal, and alternate interior angles are congruent. That's why this is also x. But angle C intercepts arc BD, but an inscribed angle is half its intercepted arc. So if this is x, this is 2x. You might also notice that angle D is a right angle. It's an inscribed angle that intercepts a semicircle. So it's half that semicircle, or 90 degrees. So if this angle C is x, then this angle B is 90 minus x. Acute angles of a right triangle are complementary. But if angle B is 90 minus x, then the arc that it intercepts, which is arc CD, is twice the measure of the inscribed angle. And with that information, we got one other thing. Arc BE, because of this diameter and this radius, these two angles are supplementary. So right here, I can say this is 180 minus x right here. So the arc that it intercepts is 180 minus x because that 180 minus x is a central angle. Okay, and so what's left to prove is that the measure of arc ED is the same as the measure of arc BE. But measure of arc ED, which goes from here to here, is EC plus CD, because C is between E and D on the circle. But an expression for the measure of arc CD is 2 times 90, the quantity 90 minus x. Measure of arc CE is x. If we algebraically simplify this, we get 180 minus x, which is what BE is. Now, there's other cases that could be made. For example, this radius could go this way, and the proof would look a little bit different. But this should give you the idea. And there's other ways to do the proof without drawing this right triangle, but that's one way. There you go. Hope that helped. If you have any questions, post a comment. Oh.